All right, section 1.8, coordinate plane. If you recall from your algebra classes, the coordinate plane is a mathematical system in which two number lines are drawn perpendicular to each other and form four quadrants. And also recall that quadrant 1 starts here in the top right, and we go counterclockwise to quadrant 2, 3, and 4. The x-axis is the horizontal number line. The y-axis is the vertical number line. Points in the plane are ordered pairs, x comma y, and the point 0, 0 is the origin. When 2 points lie on a line that is parallel to the x-axis or y-axis, find the distance between the points by calculating the absolute value of the difference between the x-coordinates or the y-coordinates. So our examples here, we're going to use the graph to calculate the length and midpoint of each line segment. So number 1, we want to find the length of line segment BC. Well, point B is at 7, 3, and point C is at 4, 3. So if we want to find the length, well, we could either count the squares, or I can take the absolute value, oops, that should be negative 7, of negative 7 minus 4, which equals 11. And then the midpoint would just be half of that, which is 5.5. If I wanted to plot the midpoint, it would be at the coordinate 5.5, comma 3. Okay, and for PQ, well, point P is at 7, comma 6, and point Q is at 7, comma negative 2. So here our x value is the same, so we're going to find the absolute value difference of the y values. So it'll be 6 minus negative 2, or 8, and then the midpoint would be half of that, or 4. So that means the midpoint would be at the coordinate 7, comma 4. To find the distance between 2 points that do not lie on a line parallel to the x-axis or y-axis, we can use the distance formula, which says that distance is equal to the square root of the difference of your x value squared plus difference of the y value squared for any points x1, comma y1 and x2, y, comma 2. So meaning for any two ordered pairs. The midpoint of a line segment is the point halfway between the endpoints of that segment, and we can use the formula that midpoint is half the sum of the x values, comma half the sum of the y values for any points x1, comma y1 and x2, comma y2. Notice the midpoint, your final answer will be a coordinate, so you want to keep it in parentheses. Alright, in these examples we're going to find the distance between each set of points, and we're going to leave our answers in simplest radical form. So in number 3, if I want to find the distance between m and n, I'll take distance is equal to square root, take difference of my x values. And remember, similar to finding slope and also when we find midpoint, it does not matter which order you go in, so which value I call x1 or x2, as long as I go in the same order. So I'm going to take negative 2 minus 4 squared plus 3 minus negative 6, which will become a plus 6 squared. And then we simplify. So again, square root, negative 2 minus 4 gives me negative 6 squared, plus 3 plus 6 is 9 squared. Still simplifying. Negative 6 squared is 36. Go. And 9 squared is 81. 36 plus 81 is 117. Now that cannot be simplified in simplest radical form, so we're going to leave it as is. If it said to round to nearest decimal, it would be about 10.8. Okay, number 4, finding the distance of line segment DE. So distance equals square root 4 minus negative 8, so it's become a plus 8 squared, plus 2 minus negative 3 becomes a plus 3 squared. And then simplifying. Let's see, 4 plus 8 is 12 squared. 2 plus 3 is 5 squared. Still simplifying. 12 squared is 144. 5 squared is 25. Then 144 plus 25 is 169. And that is the perfect square of 13. Okay, the next examples I want you to try on your own, and I'll provide you with the answers so then you can check your work. In 5 and 6, you're using the distance formula. 5 says, how far is the subway ride from Jackson to Elm? So when you use the distance formula, as a final answer, you will get the distance equals the square root of 125. And just a quick review of simplest radical form, if I want to simplify that, I'm looking for the largest perfect square that divides into 125. So I can break that down. That's the square root of 25 times square root of 5, and then square root of 25 is 5. I cannot simplify the square root of 5. So square root of 125 in simplest radical form is 5 root 5. In number 6, you will get that distance equals the square root of 10, which you cannot simplify. In 7, to go from north to south, you can actually just count the squares or take the absolute value of their differences. And actually, I should put miles in all these. In number 7, you will get 9 miles. And then in 8, to calculate how far is from Central to Elm, you will get a total of about 9.7 miles. So if you want to try those on your own and then check your answers. All right, let's look at 2 examples where we want to find the midpoint for each line segment given the endpoints. So remembering our formula, for midpoint, we're going to take the sum of our x values divided by 2. So I can take 10 plus 8 divide by 2, then comma, sum of the y values divide by 2. So simplifying, I will get 18 divided by 2, comma, negative 10 divided by 2. So my midpoint for line segment AB is 9, comma, negative 5. Notice midpoint is an ordered pair. Okay. And then in 10, if I want to find the midpoint of line segment XY again, sum of the x values divided by 2, and then sum of the y values divided by 2. And simplifying, we have 7 divided by 2, comma, 7 divided by 2. And midpoints can be a decimal. So my midpoint of line segment XY is 3.5, comma, 3.5. Or you could keep it as a fraction. You could write it as an improper fraction or a mixed number. For midpoint, it does not matter. All right, last 2 examples. In 12 and 13, we're given the midpoint and one of the endpoints. In 12, we know that the midpoint of DG is negative 1, comma 5, and one endpoint is D, 1, comma 4. We want to find the coordinates of endpoint G. So if you think about it, negative 1 is our x midpoint, and that will be paired with, we know D's coordinate, x coordinate is 1. So keeping in mind the midpoint formula is x plus x divided by 2, y plus y divided by 2. Well, instead of writing m for midpoint, I know my midpoint, my x midpoint is negative 1. I know one of my x values is 1. I don't know the other, but then the formula says you would divide by 2. Now, to solve this, let's get rid of that fraction. So you could think, okay, if I make this a fraction, and then I can do the cross product. or you could think, right, multiply both sides by 2 to get rid of that fraction on the right. Either way, we get 1 plus x equals negative 2. Subtract 1, and x is negative 3. Then same idea for the y. We know our y midpoint's 5, and one of my y coordinates is 4. So I will have 5 equals 4 plus y, divide by 2. If I multiply both sides by 2 or do the cross product, I get 4 plus y equals 10. Subtract 4, and y is 6. So that means that G has coordinates negative 3, 6. Same idea in 13. If you want to hit pause and try 13 on your own and then check your answer, it might not be a bad idea. Alright, let's start with the x. So x midpoint 9, one of my endpoints 11. So 9 equals 11 plus x, divide by 2. Let's simplify and then get x by itself. We get 7. Same thing for the y. Y midpoint, one of our y endpoints. So I have 0 equals 3 plus y divided by 2. This one's actually not too bad. Do the cross product, we get 3 plus y equals 0. So y is negative 3. And that tells me that J has coordinates 7, negative 3.